Hi GOH, this is Unit 4, Lesson 4, and today we're going to construct a circumscribed circle. This is definitely a more advanced lesson. It's an honors lesson. I'm going to do the best I can I'm doing it on my computer with the compass on the smartboard, but it is a little tricky to do. So I'm just reading from the top. Circles and triangles have amazing relationships that border on being unbelievable. Curious students should do an internet search on either the Euler line or the 9-point circle to see some of these connections. We will be examining two such relationships. In this circle, we will look at the circle that circumscribes a triangle. So what exactly does that mean? A circumscribed circle is a circle which passes through all three vertices of a triangle, is known as a circumscribed or circumcircle of the triangle. Every triangle has one and only one circumscribing circle. So again, it's a circle that passes through all three vertices of a triangle. Look at exercise 1. Which of the following is a circle circumscribed about a triangle? So if it's circumscribed, it has to pass through all three vertices of the triangle. Okay, and hopefully you guys said choice 2. Okay, so this one right here. So the circle is touching all three vertices of the triangle. This is a circle that is circumscribed about the triangle. All right. Choice 3, if you thought it might have been choice 3, is a circle that's inscribed. Okay, that's an inscribed. The circle is inside the triangle. All right, strangely enough, the circumcircle has a very close relationship to the perpendicular bisector of a segment. So for exercise 2, we're going to construct the perpendicular bisector of sides AB and BC. So that's my favorite construction because it's nice and easy, so you can do it along with me. To do the perpendicular bisector, you open your compass more than halfway. I draw half a circle. And then I move over to the other point, point B, and I'm going to be off my page, so I just have to do this carefully so I can grab my compass. I move to B with the same setting, and I draw a half a circle. Where those two arcs meet, I'm going to use my straight edge, and I'm going to draw a line. So that line right there is the perpendicular bisector of AB. I'm going to do the same thing. Let me switch colors though so you can see the different colors. Now when I do it on my paper I don't switch colors, but for here I can so you can see the other construction. I want to do a perpendicular bisector of BC. So same thing, I put my compass on B, I open it more than halfway, and I draw a half a circle. I move over to point C with the same setting that I just used, and I draw half a circle. Well, the arcs need to be, make sure the arcs are meeting on the top and the bottom, or in this case, the left and the right. Where those two blue arcs meet, I'm now going to take my straight edge, and let me just fix my line, make it a little bit straighter here. I'm going to fix this line, and I am going to that right there is the perpendicular bisector. Now where the two perpendicular bisectors meet, okay, so the two, I know you got lots of lines going on right here, so I will put a big dot where those perpendicular bisectors meet. I'm going to make it green just to have a different color right there. So the two perpendicular bisectors meet right here, and they said that I should call that point D. All right, so that point D, I'll move it out of the way so you can see it a little bit. This is point D where the two perpendicular bisectors meet. Now, why is D equidistant from all three vertices? D is equidistant from A and B because it's on the perpendicular bisector. If I was connect A to D and B to D, and B to D and C to D, D is on the perpendicular bisector, so D has to be equidistant from them. So D is equidistant from A and B. It's on the perpendicular bisector. D is equidistant from B and C because it's on the perpendicular bisector. So basically, it must be equidistant from all 3 points. All right, the distance from A to D and D to B and D to C is all the same. So I can put my compass now on D and I can draw a circle. So if I put a compass on D, since the distance from D to B and D to A and D to C is all the same, I can put my compass on B and draw a circle, and that circle should touch every single point of the triangle. Now you can see I'm a smidge off at C, so you want to do this and be as exact as you can, so that circle now is circumscribing triangle ABC. All right, since AD equals DB equals DC, then D is the center of the circle, and the circle will pass through all three vertices. Point D actually has a name. It's called the circumcenter. All right. I'm just giving you a second if you have to copy anything down. If you need more time, though, why don't you pause the video? Now on the back, the fact that all three perpendicular bisectors will intersect at the same point is known as concurrence and allows us to find the center of the circumscribing circle. This is known as the circumcenter. I already mentioned that. For triangle EFG shown, we're going to construct the circumscribing circle and mark the circumcenter as point M. And as always, you have to leave all of your construction marks. All right, so we're just going to do this one. We are not going to do exercise 4. All right, so you have to construct two perpendicular bisectors. Where the perpendicular bisectors meet is the circumcenter, and I can put my compass on that circumcenter, and it'll be the same distance away from all three vertices. I'm able to draw a circle circumscribed about the triangle. So I'm going to draw the perpendicular bisector of EG. So I open up my compass. I need it open up more than halfway. I draw an arc. I move it over to point G with the same setting that I just used, and I draw an arc. Where those two arcs meet, I'm going to use my straight edge, and I'm going to connect those points of intersection. I'm just going to fix my line a little bit. There we go. And I need to draw two perpendicular bisectors, so I am going to change the color. I'll do the next one in blue. All right, and I will do it. It doesn't matter. I can do GF. I can do EF. It really just doesn't matter what I do. All right, I don't know if I have more room over here. Whoops. I didn't mean to do that. That's for sure. How do I get this back? There we go, because that would have changed things up a bit. So I'm going to take my compass and I'm going to put it on F. I'm going to make sure that it's open more than halfway. All right, it's definitely open more than halfway. I'm just going to close it a little just so my arcs are not off the page. It could have been open that much though, but I'm working with a smartboard lesson, so it's a little harder. Put it on E with the same setting. Where those arcs meet, I'm going to take my ruler and I'm going to draw a line. Now I have to keep extending this because I wasn't meeting the other line. Where those two lines meet is the circumcenter. So those two lines, again, I'll do a green dot. Those two lines meet here outside of the triangle. But that point right there, that green dot that I just drew, is the same distance from E, and it's the same distance from F because it's on the perpendicular bisector, and it's the same distance from G and E because again it's on the perpendicular bisector. The circumcenter is outside of the triangle because it's an obtuse triangle, and that's actually what they're asking me in exercise 4 right there. But again, all I do is I take my compass, I put it on the circumcenter, I open it up, and I'm going to change my color right here. I think I'll do it in purple. I open it up so it is the length from that point, I didn't name the point, to G. Okay, I want to make sure, so the distance from that circumcenter to every single point, okay, is the same. Let me just see if I'm going to get every point. Looks like I'm getting every point. I was just testing it out. I'm pretty darn close. Okay, and again, I drew that point G, that green dot, pretty big, so you got to make sure that you're right on the center of where those meet, which might have been why I was off a tiny bit. Okay, so I can construct a circle circumscribed about a triangle. And we already said exercise 4. Why do you think the circumcenter for this triangle was outside, when for that last exercise it was inside? And it's because triangle EFG is obtuse that circumcenter is actually outside the triangle. All right, we are not going to do exercise 5 together. It's just another one. It's a right triangle, but we will practice some of these in class tomorrow.